Okay, class, today we're going to talk about inverse variation. This is different from what we learned the day before, which is direct variation. So there's two different types of things. For an inverse variation, to get k, which is our constant of variation again, to get k we have to take x times y. So we get xy equals k or y equals k over x. Either one of these, it's the same equation, because if we take the equation xy equals k, if we got y by itself, we divide by x on both sides, so y equals k over x is the same equation. And this is what an inverse variation is. Okay, and again, the constant of variation for an inverse variation is k. All right, and k is the product of x and y. All right, so let's look at some examples here. All right, some examples. Example 1, it says writing an equation given a point. So we know that it says suppose y varies inversely with x and y equals 7 when x equals 5. Write an equation for the inverse variation. Well, if we know the equation for inverse variation is xy equals k, all right, and we know that x is 7 and y is 7 and x is 5, we're going to plug those numbers in for x and y. All right, so I'm going to plug 5 in for x, so I'm going to get 5 times, and then I'm going to put 7 in for y, so this will give me my constant of variation, which is 35. So I know that k equals 35. And then the second part of this is I rewrite the equation xy equals k. Okay, I rewrite the equation xy equals k, but this time I actually fill in what k is. So I'm going to put that in for k. So we get xy equals 35, and this right here is our equation. So again, you write the equation twice. The first time you plug in x and y to get your k, then you rewrite the equation again and you plug in the 35 where k is. And that's how you write the equation of an inverse variation. Okay, you're basically using a different equation than you did yesterday with direct variation. All right, so finding the missing coordinates. So we have the points 3, 8, and 2y. Our points on the graph of an inverse variation. Find the missing value. Okay, here's what we do with this. All right, we have the point, we have an xy here, and we have an xy here. If those are both on the same graph of an inverse variation, when we multiply these two numbers together, these two and then these two, we should get the same constant of variation, the same k. All right, so these two, so xy on one point should equal xy on the other point. So then we're going to plug these values in. We're going to 3 times 8, so we get 3 times 8 equals, and then here we have x is 2, but then we don't know what y is. So we're going to leave y as y. All right, so these should be equivalent statements. 3 times 8 should give you 2y, because if they're the same equation, they should have the same k. And to find k, you multiply your x and your y. So 3 times 8 gives us 24. So 24 equals 2y. Basically, we're just solving an equation. Now we divide both sides by 2. And so we get y equals 12. So this is our missing coordinate, which is 12. So that's how you would find the missing coordinate of an inverse variation. If both points are from the same inverse variation, then that will be how you do that. Okay, example 3. The weight needed to balance a lever varies inversely with the distance from the fulcrum to the weight. Jeff weighs 130 pounds and is 5 feet from the fulcrum, or from the lever's fulcrum. If Tracy weighs 93 pounds, how far from the fulcrum should she sit in order to balance the lever? And again, because this is an inverse variation, we should have that the two k's are equal given the two situations. Our xy should be equal our xy. Okay, we have two x's and y's. All right, for this one, for Jeff, we have 130 pounds and 5 feet, all right? And then the other xy is Tracy is 93 pounds. How far? This is going to be our y here. Okay, so we have xy, xy, and then xy. We're going to plug these in here, and we should get an equation that equals out. So our x on Jeff is 130 pounds times our 5 feet from the fulcrum equals. And then we do our other side. We have 93 for x, and then we have just y. So we solve this just like we did example 2. It's just we now have a word problem to go with it. So we take 130 times 5. We should get 650 equals 93y. And then we've got to get y by itself, so we're going to divide by 93. And we will get y equals whatever 650 divided by 93 is. Pull up my little handy-dandy calculator here. We get 650 divided by 93. All right, so we get 6.9829. Let's go ahead and just round to the nearest tenth. If we round to the nearest tenth, we're going to get actually 7 because your 9 tells you, the 8 tells you to round the 9 up to 0, but then that means we have to move the 6 up. So we get 7. And that we need to label it because it's a word problem, and that's distance. So it should be 7 feet. So that's how far Tracy should be from the fulcrum. All right, let's look at example 4. All right, in example 4, we're going to decide whether something is a direct variation or an inverse variation. Okay, if it is an inverse variation, our x times y will equal k. All right. If it is an inverse variation, our y equals kx. All right. And then to find out what k is, we divide both sides by x. So our k for a direct variation should equal y over x. So this one is direct. This one is inverse. So in one of the cases, the inverse variation we multiply, on direct variation we divide. And what has to happen is this relationship has to be the same all the way down our chart. Now it's easier to go ahead and check for inverse variation first. That means you multiply the numbers across until you see if you have the same relationship. So let's just go ahead and check and see if it is inverse. So we take 2 times 5, which gives us 10. And then we take 4 times 10. So 4 times 10 actually gives us 40. So right away we know it's not an inverse variation because they're not the same value. These aren't the same k's. All right, and then, so now we want to check and see if it's actually a direct variation. Maybe y divided by x is the same. So now we're going to take y divided by x. So we do 5 divided by 2. That gives us 2.5. Then we do 10 divided by 4. 10 divided by 4. Okay, that again gives us 2.5, so we may be onto something. Now we take 25 divided by 10, and that gives us 2.5 also. So we now know this one is a direct variation. Now it says to write an equation to model this situation. Since it's a direct variation, our equation is going to be k equals y over x. So our k we found here. This is what you get when you get here. This is your k. So then you just go plug it into the correct equation. For a direct variation, it's y equals kx. So we go ahead and plug in 2.5 for k. So we get y equals 2.5x. You could also use this one up here, and you could have got y over x equals 2.5. Either one of these would be correct. Either one of those would be correct. So you do actually have to write the inverse or direct variation equation. So you are just going to need to know these two equations, y equals k, and k equals y over x. You just need to know those two formulas. All right, so on letter B, let's check for inverse variation first because it's easier to do. We just multiply across. 5 times 20, we get 100. 10 times 10, we get 100. And 25 times 4, we get 100. So this is our K. And to do that, we had to multiply, which means it's an inverse variation. So we call this inverse variation. And then the equation for inverse variation is xy equals k. So we fill in 100. So we get xy equals 100. And that is the equation for our inverse variation. So one of them was direct, one of them was inverse variation. You're going to need to know those formulas for each kind of equation so you don't get them mixed up. And that is inverse variation. Thank you for watching.